Welcome to Chapter 4, everybody. Here is an outline of what we're going to cover in Chapter 4, with the exception of 4.4 and 4.5 being put together. Now, Chapter 4 talks about quadratic functions and quadratic equations. We'll talk about what that means and we move along. But today, I really want you to know that we're going to talk about vertex form, and tomorrow in the next lesson, we'll talk about standard form. So everything that you see in chapter 4 is going to be some type of squared problem. That's where we get the name quadratic from. And you can see we're going to do a lot of things with those quadratics. All right. So in chapter 4, section 1, we talk about quadratic functions and we're going to transform them. Now these transformations are the same as they were in chapter 2, section 6. So you might want to go back and pause and look that over. When we were in chapter 2 and chapter 3, we primarily focused on linear functions. Linear functions usually just had x to the first power. Now they might have x to another power, or a variable to the first power, but I misspoke. It's always to the first power. So we could have had something like m to the first power or c to the first power. But if your highest exponent is a 1, that's what we call linear. And you're probably in your mind thinking y equals mx plus b, which that's true, that is a linear function, but it's because x has a power of 1. And the different forms that we talked about when we went into graphing were the slope-intercept form, standard form, and point-slope form. And I apologize, I'll get this fixed on yours. This should be y minus y sub 1 there, but I'll get that fixed up on yours. And now what we need to do, and again, I'm going to get this fixed up on yours. This should say chapter 4, and when you get yours, it will say chapter 4. We're going to move into quadratic functions. Now, quadratic functions are functions that have x to the second power, or maybe a different variable. It might be r to the second power, but the highest degree is going to be a degree of 2. All right. There are 2 types of forms that we're going to talk about today. So like you can see up here, we have 3 types of forms, right? And you were hopefully very familiar with those 3. We're going to move into vertex form today, and we'll talk about standard form in the next lesson. Sorry, my husband's packing lunches, so if you hear some background noise, that's what's going on. Got to make sure I eat. Chapter 2 and chapter 3, so linear functions make straight lines on the graph. So that's linear functions making straight lines. Quadratic functions, those are those U shapes you see. Now you may have gone over this briefly in Algebra 1. You may have spent a whole chapter in it in Algebra 1, depending on what class you were in. But really, quadratic functions are purely an Algebra 2 topic. So we're really going to take time and talk about them for at least 9 days of class. Okay, so quadratic functions are going to have this U shape instead of a straight line shape. And you can see the squared happening on both of these items. All right. So a quadratic function is a polynomial function. Polynomial means there's terms with 1 or more variables in which the highest exponent of a variable is 2. Here are some examples of quadratics. Please notice that we have r squared. There's the highest variable of 2. If in the next example we were to distribute a couple of binomials together, you can see we would end up with x squared. And then in the last one, I wrote it on purpose, not in order, but you can see how the highest term is x squared. And that's what makes all of these quadratic functions here. All right, so everything in blue is in vertex form. Everything in red is standard form. Everything in blue is what we're going to go over today. Everything in red is what we'll actually go over in the next lesson. So vertex form takes the form that we studied a lot in chapter 2, section 6, when we were moving things up, down, left, and right. This A number in the front is a stretch or compress. This H number moves it left or right, and this K number moves it up and down. Those will all get filled in with numbers. So we might have a 2, a 3, a 4, or something like that. We might even have decimals. So the vertex in vertex form is pretty easy to find. It's just the opposite of whatever's in here. Now here's what I'm hoping. I hope you guys remember this from absolute value. It's so much like absolute value. So the vertex is the opposite of the inside and exactly the number in the back. So just like chapter 2, section 7, when we did like, I'll just write absolute value. So as long as you understood how to graph absolute values, these are going to be pretty simple for you because the vertex is your first step. The axis of symmetry is always x equals h, just like it was in absolute values. So again, it's nice to have that flow. So as long as you understood what you were doing in chapter 2, section 7. Now, tomorrow we'll talk more about this red side, okay? It's a little more difficult to find the vertex. It's not just given to you in an equation. You have to work for it, but I'll walk you through that tomorrow instead, okay? So one form at a time. The most important thing to find is absolutely the vertex. It is the number one most important thing to find. I have two examples right here. If you look at them, this one, that's the vertex. I'll mark it with a V. And this one here, there's a vertex. I'll mark it with a V. Those are the most important points because they're the beginning points of your parabolas, or they're the central point. Okay. This one on the left is a maximum. See how it has like a top, and this one on the right is a minimum because it's at the bottom. The parabola, it's just a really fun word. A parabola is a graph of a quadratic. So I was like, hey guys, look at this parabola. I'm just talking about that U shape. The domain, if you notice, since it goes left and right forever, is always x equals all real numbers, unless it's a word problem. Okay, so hopefully you understood domain and range from Algebra 1, but if you didn't, you can also go back and study Chapter 2, Section 1 of Algebra 2. Now the range is where it gets kind of tricky, okay? The range is either going to be, I'm going to erase all these extra marks because they're getting to be too much. The range is either y is greater than or equal to the minimum, or if it has a maximum, it's y is less than or equal to the maximum number. And I'll show you that, okay, as we go along, but it's always pulled from your vertex. So the mins and the maxes are always pulled from your vertex, so is the axis of symmetry, okay? For example, in this graph here, let's look at this red graph, okay? Do you see this green line? I may as well trace it in green. That's your axis of symmetry. And you can see that the axis of symmetry occurs at x equals -3. And that is because the vertex happens at -3 too. All right, so now that I've kind of introduced quadratics, quadratic means x squared, and now that I've introduced their shapes as being parabolas, it's time to go ahead and try a couple on our own, okay? Here we are, two main ideas. How do we graph them if they're in vertex form? And number two, how do we make an equation given a graph? So we're gonna go like ice to water and water to ice. I'm gonna give you an equation, you're gonna graph it, and then I'm gonna give you a graph and you're gonna give me the equation. So we're gonna go ice to water and water to ice. Part one, how do we graph them if it's in vertex form? Well, first of all, if it's in vertex form, give it a big fat smile because it's gonna be so much easier than standard form tomorrow. Example one, given this particular graph, or this particular quadratic equation, notice the squared, find the following, the vertex. Well, let's start with the vertex. The vertex is the same as it would have been in Chapter 2, Section 7 with absolute values. It's opposite of the inside number. So let me go ahead and highlight that with this gray highlighter. So opposite of -4.5 is positive 4.5. And then the number in the back, that's your second number in parentheses, -2, and you don't change it. All right, so the vertex is from this minus h value and this plus k value. So the opposite of the inside and exactly what you see in the back. The axis of symmetry is going to be x equals, so it's a vertical line. I'll write VL for vertical line. X equals, and it comes from up there at your vertex. So please notice that it always matches, and it has to be x equals. Now this one, because it's positive up front, I'm going to go ahead and put a big fat plus sign here. Because it's positive, it's going to open like this. So it will have a minimum. In other words, it will have a bottom. Now, if you don't know what that is, that's okay. I'll show you on the graph, okay? So I'm going to put an asterisk here to remind you visually why it's a minimum. Now, the minimum value is a y value. It's the lowest point on the graph, and in this case, it's going to be this y value of -2. So I'm going to write y equals -2. I'm going to draw an arrow so you can see where it came from. So you see the axis of symmetry came from the vertex and the minimum value came from the vertex. Some of you might not have grasped why it's a minimum and not a maximum, but I will show you on the graph. So visual learners, just hold on, it's coming. Now your domain. We've already talked about domains. This domain is going to go left and right forever, so it will be x equals all real numbers. I'm going to save the range until you can see the graph. Now it's time to actually graph this parabola. And it will be a parabola because it's the graph of a quadratic. So I'm going to plug in, this is huge. I wish I could come out of the screen and be like, pay attention, stop playing whatever you're doing. I need you to put this, that's my dog, vertex right there in the middle. The vertex always goes in the middle. Absolutely, it is a must, okay? And then what you do, hopefully you have your volume on, you surround the x value of the vertex with numbers that would surround it on a number line. So tell me, what's a little lower than 4.5? How about 4? What's a little lower than 4? How about 3? What's a little higher than 4.5? 5. What's a little higher than 5? 6. Now, for all I care, you could go way lower, and you could do decimals if you wanted to. I don't think it would be smart. I like using whole numbers, but really you could have done like 2 and 1 here. As long as you're doing 2 points smaller than the vertex and 2 points in the x weight value bigger, then you're doing great. Now what we're going to do is we're going to plug those numbers in, okay? So vertex goes in the middle, exclamation point because it's really important, and then you surround it, a couple lower, a couple higher. Now it's time to see your like plug and chug skills. You're substituting in. So this is the equation from up top. So if you're not sure where I pulled that, I pulled it from right here. It's just the equation we're graphing. We need to plug x in. So you see this x? I think I could even think I can do a quick copy. I think I could do a paste. And I think I can just type over this with a 3 like that. Now, you can do complicated math and potentially get it wrong, or you could just use a calculator. So 3 times 3 minus 4.5 squared minus 2, and that's going to be 4.7. And then I'm going to do the same thing. Let's see, those of you who like to see it, there it is. And I'm going to plug in 4 for my x, 3 times 4 minus 4.5 squared minus 2, negative 1.25. And now I can prove that this is negative 2. I'll show you what that looks like when I prove it here. Okay, so what was that? I'm plugging in 4.5. 3 times 4.5 minus 4.5 squared minus 2. And you can see that would truly give us negative 2. Okay, so if you wanted to see it, there's why we got negative 2. Time to plug in 5. So my visual learners, if you like to see what I'm doing, here it is. Putting a 5 in there for x. If you hear any background noise, that's my kid not going to sleep. Okay, it's fine, whatever. That's why my husband's a superstar. All right, and then we're going to put in 6. Now, maybe you fast forwarded that part of the video because you're like, I know what I'm doing. I hope so. I mean, I would really love it if you're making sure you're using your calculator. All right, I'm going to get out of that now and plot those points. So hopefully plotting points, we go to the x-axis at 3. Here's, let's see, there's 3. And we're going to go up 4.75. So let's see, that would be 5, right? All right, I didn't mean to write with a highlighter. So if I go over 3 and up 4.75, let's see, 2, 4, there's 4.75. Over 4, here's 4. Here's 4, and what am I going to do? I'm going to go down 1.25, so here's down 1. There's down 1.25, because there's down 1. over 4.5. So here's 5, here's 4.5, and down 2, and over 5, and down negative 1.25. And I already have that mirror image because I skipped evenly. And 6, since I did a good job there. And you can see we have this really nice parabola here. Now the only thing I didn't ask for, which I'll put a little part in here for you, you really need to say how it transformed. Oh, it's right here. Transformations of the parent function. Boop, boop, boop. So the transformations, let's just go ahead and look up here. The 3 in the front. The 3 was an indicator of a vertical stretch. So the 3 in the front. And we learned this back in chapter 2, section 6. Okay. So this 3 was a vertical stretch. This is a right 4.5. So I'll write right 4.5. What was the number in the back? That's a down 2. And that's a parent function x squared. And I'll make sure I indicate that on yours. All right, so we had a vertical stretch, we had right, and we had down. And you can see that that is absolutely true of that. All right, now in the next one, I'm going to teach you a little shortcut on how to use your calculator. Now, if you liked this plug and chug method, that's great, go for it. However, you do have wonderful calculators at your disposal that I'm going to help you with your exercise. So the vertex is just like absolute value. So it's -1 and 3.5, just like it was with absolute values, except with a U shape instead of a V shape. The axis of symmetry is x equals -1. And I did realize I didn't do the range in the last problem, so I'll come back, I promise. In fact, now is a good time to do that. I apologize, okay? But I was going to show you why this had a minimum. That's my bad, okay? So sorry, I had to rewind. I wanted to show you why this was a minimum. And you can see right here, it's because it is the bottom of the graph. See how it has like a bottom part to it? That's minimum. I'll label that as a V, and I'll label it as a minimum. And then the range, I do realize I did not do the range. See how the minimum happened at -2 and it goes up forever? So I'm going to write the fact that it goes up forever and is greater than or equal to -2. And that always corresponds with a minimum and maximum value, which always corresponds with that value there. So you can see this parabola goes up forever from the bottom value of -2. Sorry, I kind of didn't get that filled in, but hopefully I did okay now. All right, I am going to save for real. I'm going to put a circle here. I'm going to save that for the graph. 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 But I am going to go ahead and show you how to do this. I already showed you how to do it once by hand on the calculator. You can plug in x's. However, before we begin, remember what goes in the middle? Hopefully you remember that the vertex goes in the middle. So my vertex was -1 and 3.5. Let's count up. So what's a little lower than -1? -2 and -3. I just like to count by ones. I just think it's so much easier. You can count by something else if you want to. Now, what are two numbers that are lower than or higher than -1 on the number line? How about 0 and 1? I'll add in a little space there. Let's get our calculators ready. So watch carefully. I'm going to show you how to kind of cheat using your calculators. Go to your y equals. That's the top left button of your calculator. I'm going to clear what I have in there. I'm going to type this in. -1/2. You know what? I'll just do -0.5. Parenthesis x plus 1. Parenthesis squared plus 3.5. Now you're more than welcome to do this by hand just like I did in the last one. If you hit second in graph, you can see this word table. So that was second in graph. You can see this table. And then you should be able just to plug in numbers. So see how I'm just typing the numbers in, and it's giving them to me. So like 3 gave me a 1.5. -2 gave me a 3. -1 gave me a 3.5. Now watch this. Watch what happens when I hit 0. It gives me a 3. It just plugs it in for you. Now again, should you be able to plug it in yourself? Yes, you should. 1 gives you a 1.5. So I did use my calculator to help me here. However, you don't have to. So don't use as an excuse. You can always do -1/2 times, what did we plug in? Like -3 plus 1 squared plus 3.5. You can definitely plug it in by hand and get the answer the same way. It's just if you know how to use your calculator to shorten it, definitely worth it. Let's graph these points. So over 3, up 1.5. I love that I didn't give you enough room. Totally fine. 1, 2, 3, up 1.5. That's right there. Okay. Let's go -2 and 3. 1, 2, 3. Let's go -1 and 3.5. 3.5. Let's go 0, 3. And let's go 1 and 1.5. You can see that U shape. That's called a parabolic shape. Okay, this is called a parabola. Now let's go back and do the domain and range. And you can see as well, let's go over here. Let's label V for our vertex. Can you see that it's a maximum? See how it has a top? That's a maximum. And you can see your axis of symmetry right here where x is -1. Now let's finish by kind of putting this together, okay? So we have our vertex. That looks good. We have our axis of symmetry. That looks good. This parabola has a top to it. So since it has a top, it has a maximum. And the maximum happens at the y value. So what was the y value? 3.5. I'll draw an arrow. This parabola points left and right forever. So your domain is all real numbers. The range this time is less than or equal to our vertex number. And that is because, remember, these two always correspond. That's because it's pointing down. See how it's pointing downwards? So it's less than or equal to. And now for the transformation. So these are old school from chapter 2. The negative in the front, I'll just circle it as I go along. The negative in the front is a reflection. That's why it's upside down. Specifically around the x-axis. The 1/2, and we're doing it from x squared. The 1/2 is a vertical compression. The +1 we learned in the past is left 1. And the plus 3.5 is up 3.5. And that fills in everything we need to know. Okay, so you're going to practice that a couple of times on your own. Typically, kids have trouble with mins and maxes, and kids have trouble filling in their XY chart. So just call me over when it's time for you to practice. Now, part 2. Hopefully you've made it this far. I only have one example like this because the 5 steps, they should go perfectly for you, okay? Copy every step. Some kids try to take a shortcut. They think it's always the slope between the first 2 numbers, and it's not. So please don't just naturally think it's the slope, okay? That would be a really bad thing, and that happens in the quiz all the time. So this time we have this parabolic movement of a jump of a dolphin. What quadratic function, so that means what x-squared equation, models the path of the dolphin's jump? So I have steps here. So in other words, you have a graph. Long story short, you have a graph. You need an equation. That's what they're asking you for. So my steps are identify the vertex and label it as h and k. So the vertex is the very, very tippy top. And I see that happening right here at 3, 7. So that's your vertex. I'll put that right here. That's h and that's k. Very special x's and y's. They have h and k as labeled. Find another clear point and label that as x and y. So another really clear-cut point on this parabolic path, I think, happens right here. See how it comes through the grid lines like perfectly? That happens at 9, 4, not 4, 9. So this is just another point. You would do this whether it's a word problem or not, okay? So my another point is 9, 4, and I'm going to use x and y to represent those, not h and k because they're not the vertex. Now it's time to put it in vertex form. So I will write, actually, I'm going to go ahead and try to do a quick copy and paste image. Perfect. Replace y with 4. I'm going to highlight them as I use them. equals, we don't know what A is. Replace X with 9. I'm going to highlight them as I use them. Minus, replace H with 3. I'm going to highlight them as I use them. Squared, plus, replace K with 7. All right, and step 4 and step 3 are joined together. It's time to solve for A. So you need to use your Algebra 1 skills here. We need to solve for A. 4 equals A times 6 squared plus 7. 4 equals A times 36 plus 7. Kids mess this step up all the time. Make sure you square it. That's pretty much what I'm trying to get at. 4 equals 36A plus 7 minus 7. Negative 3 equals 36A. Divide by 36. If you reduce that, you get negative 112. I feel like you need to see that though, because I still feel like kids are not knowing how to work their calculator. So just take a look. Negative 3 over 36. Math, enter, enter. Negative 112. So if you're not sure how to reduce fractions, please use your calculator at this point. So there it is. And now that was all step 4. I guess I'll try to give you a bigger box because I thought we could fit all that. That's okay. Shrink it down. If I don't give you a bigger box, don't overstress about it. Shrink it down. And now step 5, write the quadratic in vertex form, filling in H, K, and A. Okay, so one more time. I think I can paste that image again. These directions say to fill in A and H and K. Leave Y and X alone. Y equals the A value of negative 112, so it's reflected and compressed. X minus, what was H? 3. Quantity squared plus K was 7. So this is the quadratic equation that represents this graph. If you follow those steps, you won't go wrong. I'm just going to warn you one more time. Right here, in this step, with this A thing, this is where I see kids go wrong. And what I typically see kids do is right here, they do 36 plus 7 instead of just putting the 36 in front of the A. All right, follow those steps and you'll be good to go. So 2 things you went over today. Number 1, you went over the graphs of quadratic functions. And we talked about domain, range, mins, maxes, vertex form is all we talked about today. We didn't do any other form. And then you learned how to make the equations today. All right, I'll see you soon.